appreciate that for giving us time to us this afternoon.
Thank you. It was a pleasure to be on this side of the podium. Not always a pleasure, but mostly a pleasure to be on this side of the podium. I'm going to talk about what sounds like a little bit of an esoteric topic, but as Ruth said, it relates to some work I just finished as the chair of a committee that was still the Institute of Medicine then, and I think it may be the last report that is officially called the Institute of Medicine report before the name change to the National Academy of Medicine. It has implications that are broader for this sort of narrow slice in ways that I will articulate. So let me do a little bit of background with you, and I'm going to show you an infographic in a second that even does a better job on showing background. But for the moment, let me just sort of try to answer this question. So MRT is an acronym, obviously, for mitochondria replacement techniques. In some parts of the world, the UK in particular, it's been termed mitochondria replacement therapy. On this committee, we're very careful not to characterize it as therapy because it's at a very early stage, and we didn't think that was actually appropriate. But MRT is now the commonly used acronym for this. So it turns out that there are women who suffer from mitochondrial DNA disease, such that because of the way mitochondria and its DNA are passed through the maternal line, that they have no option but to pass it on to their offspring. And so for those women who would like to have genetically related offspring, so through nuclear DNA, the only possible way to do that is through technologies like this, and I'll say more about that, of course. The alternatives for them are not sufficient to meet the desire to have genetically related offspring. So if they go through the process of conceiving normally, they run the risk of passing on these diseases, and for some women it's pretty much 100% the case. There are some examples where pre-implantation genetic diagnosis, creating embryos outside of the body through IVF and then testing them and implanting only those that are negative could be useful, but it turns out because of mitochondrial DNA disease, there's so much variation within cells and something called heteroplasmy that it's really not a reliable approach. So you may end up thinking that you're implanting an unaffected embryo, but in fact have then an affected offspring. The alternatives that are more reliable include oocyte or embryo donation, but of course that doesn't provide the genetic connection to the mother. Adoption, which doesn't provide the genetic connection to either mother or father, or foregoing having children altogether. So for these families, there really are very few good options for achieving that particular set of goals. So within the United States, there's this interesting time. So this approach could potentially prevent transmission of these particular diseases, mitochondrial DNA diseases, from women to their children. But the techniques raise safety issues never before been done in humans. So we're at a point of uncertainty, real uncertainty, as well as social, ethical, and policy concerns, which I'll talk about. Several countries are considering whether to continue with these techniques, furthest along among them being the United Kingdom. And you may know the UK had a long public discussion and then a parliamentary vote which has permitted, actually endorsed, the Human Fertilization and Embryology Authority in the UK to create guidelines by which these technologies could be undertaken and licensed within the UK. In our country, the FDA held, through their typical process, an advisory committee meeting in February of 2014, so now 2 years ago, to discuss the state of the science of these techniques in expectation that they would receive an IND license application from one or more institutions to pursue this in a research context. But that advisory committee meeting did not take on, was not addressed with taking on, and so did not take on the ethical, social, and policy considerations. And just sidebar here, the FDA doesn't have a way to do that. It isn't built into the advisory committee process. And so when they're faced with questions that are not about safety and efficacy and the science, they don't really have a way to manage that. And so the FDA requested that the then Institute of Medicine, and who's now the National Academy of Medicine, asked them to convene a consensus committee. And that's a typical process by which the IOM, NAM is asked to do work. And that committee was convened with diverse expertise and a range of perspectives, and through their process deemed to be balanced. The report of that committee, I'm going to show you the membership in a second, went through the typical internal and external peer review process that the academies uses, and then after revision, it was released. And as I mentioned, that happened in February. I'll show you that in a second. The committee, which I had the privilege of chairing, was charged with the following: to consider the ethical, social, and policy issues raised by these technologies, to assess whether it was ethically permissible for clinical investigations of MRT in humans to proceed. So the FDA realized that they're considering an IND application, investigational new drug device application. They have to decide whether to grant that for the very first use in humans, and that's what this would be. And they wanted to know whether they could do that and do that in a way that would be ethically permissible, and if so, if it was deemed to be ethically permissible, for the committee to articulate the circumstances and conditions under which such clinical investigations might be ethically conducted. Okay, so that's what we were asked to do. Here's the committee. Many of the names here you will recognize from our colleagues in bioethics. Jeff Botkin, I'm sure many of you know, is the bioethics and oversight of research at the University of Utah. The names that you don't recognize, I'll just sort of say a little bit about. David Chan at Caltech is a mitochondrial DNA biologist. Important. Walter Sharma, many of you know from the University of Wisconsin. Jim Childress, many of you also know. Alan DeCherney is a long-standing reproductive medicine physician. He was a chair of OBGYN at UCLA for many years, and now he's at NICHD, and he runs the IVF side of NICHD. Marty Falk is at CHOP and cares for children with mitochondrial DNA disease, so physician as well. Jonathan Kimmelman is an expert in oversight of research involving new biomedical technologies. Anna Mastroianni, you may know from the Law School, University of Washington. Vamsi Mutha is a mitochondrial DNA geneticist at Harvard and Howard Hughes investigator. Lori Strongen is the parent of a child who suffered from and passed away from an inherited genetic disease. Keith Whaley, you may know, is a sociologist who does sociology and a little bit of history of medicine at Princeton. All right, so that's the group. Here's a little bit of a primer. So I learned a lot about mitochondrial biology and genetics as a product of this, as you might guess. My undergraduate degree, for those of you who don't know, is in molecular biology. However, I don't remember being taught any of this. I think it was a little esoteric even for an undergraduate, even focusing in molecular and microbiology. But to remind you, if your biology is not so recent or up to date, mitochondria are organelles within our cells, which are important for the production of energy. They also have some role in regulation of the function of cells, as you see here. They contain their own genome, and there's a lot of speculation about the evolutionary connection, how this happened. It's very different than the genome in the nucleus of our cells. It's circular in size versus linear as in the nucleus. It's got only 37 coding genes versus 20 to 30,000 in the nuclear genome. There are 100 to 10,000 copies of the mitochondrial DNA genome per cell, right, versus 2 in each chromosome on the nuclear side. They inherit only maternally, so in the way that humans and other mammals reproduce, when sperm, which has a little bit of mitochondrial DNA in it, fertilizes an egg, the paternal mitochondrial DNA is degraded. So you really only have maternal mitochondrial DNA passed on from mother to children. And most interesting and problematic for some of the diseases, the mitochondrial DNA can exhibit what is known as heteroplasmy, so in which a cell tissue or individual contains more than one type of mitochondrial DNA genotype within the cell. So it's mixed up in a way that makes it very hard to predict what the disease, either inheritance or progression, will be. So I have a little infographic here, which I am proud of. This is a product of the committee's work, but I will commend it to so this is a way of sort of understanding what this is about. So what is mitochondrial DNA disease? And what's important for this in this picture is that there's pathogenic mitochondrial DNA that causes disease that gets passed on, as it says here. And there's no cure, right? So these are very diverse diseases that cause, they're really syndromes, and they cause all sorts of potential and real problems, as you see in that graphic. I don't need to read that out for you. And then we get into what is MRT. So these are techniques that could, as you see here, allow people who have this risk of passing on, there you go, genetically related child will have these diseases, and the numbers of people who would qualify for these kinds of techniques is a whopping 778 predicted births per year. Very small numbers. But let me just sort of say, okay, that's a very small fraction of the children born in this country in any given year. However, this is the first time the FDA has engaged in prospective regulation of a new reproductive technology. So what this committee had to say about MRT has very significant implications for what new reproductive technologies that satisfy the FDA criteria for oversight might see. And so the FDA gets involved when there's more than minimal manipulation of cells. And MRT certainly qualifies, and there will be other techniques that come after it. And so people in this world watching very carefully, because there's a lot at stake from their perspective. So how does it work? So you see here, I'm going to actually skip out of this at this point and come back to my own slides. Alan, what do I do here?
On the bottom,
Just
just
do this one. Come back here. Thank you. Great. So there are two techniques which are effectively, they result in the same thing, but they happen at different stages. So there is a donor egg and a mother's egg. So this is the woman who's got problematic mitochondrial DNA. This is a different color. And you see in this picture, and you pull out the nuclear genome, but along the way, you're going to suck out a little bit of the bad mitochondrial DNA as well. You take the nucleus out of the donated oocyte, and you want to put this nucleus into that enucleated egg. There it is. You inject the nucleus back in. You're going to carry a little bit of bad mitochondrial DNA in the process. Then you get a sperm fertilized, and you've got an embryo. So you're reconstructing the egg from two women. Nuclear DNA from one woman, mitochondrial DNA from the other. The second technique actually does it later. It takes fertilized eggs. So you actually starting with, rather than two eggs, two embryos, and ending up with one. So it's just later in the process, you see these are both fertilized, and then you're pulling out here and reconstructing there. So for some people, this is more ethically problematic because you've got two fertilized eggs to start with versus two unfertilized eggs. So that's the technique, all right? Clearly more than minimal manipulation from the FDA perspective, right? Because you're taking apart and putting back together either oocytes or fertilized oocytes. And then you have effectively an IVF embryo, which is implanted, and you hope that you end up with a pregnancy. Okay, everybody clear? That's about as quickly as I can describe that. All right, so the committee then is charged with an analysis of the ethical issues, and we divided that into various categories. These are not meant to be in any order of priority, but identity, kinship, and ancestry. So you've got genetic contributions from two women, so two different maternal lineages, which would introduce complexities that might affect the way that child would experience their own identity, their kinship, their ancestry, and realize that much of the way we think about our ancestry comes from that maternal line. Ancestry.com, that's what they look at when you send them your sample. It's your mitochondrial population. And so you're raised by a woman whose nuclear genome you have, but a different maternal mitochondrial line. And what we said was it's a matter for reflection that you're taking MRT and society to discuss, although it doesn't have all that much a different field and other interesting and different combinations in reproductive medicine that introduced multiple kinds of parental relationships. And what we said here is that the complexities related to this may be a little bit of a nuanced difference from what we have seen before, but not enough to justify prohibiting the undertaking of first clinical investigation of these technologies. More problematic, I would say, and more interesting, is what to say about the genetic modification of germ cells and the germ line. So we said, and this is I want to sort of highlight, different from what the UK analysis resulted in. This committee said that these techniques, these technologies result in the genetic modification of germ cells. And if that's the case, these are heritable genetic change if they result in the birth of female offspring. Right? So if you have male offspring, those males will not pass on that genetic change to their offspring. Only will female offspring pass on through their eggs, if they are able to reproduce, these heritable genetic change. So MRT does modify germ cells, but those changes are not always heritable. They're only heritable in the case of females. Okay, that's an important distinction, as you'll see as we get deeper into the discussion. There have been lots of discussion about genetic modification and the ethics therein. So safety needs to be understood, and how do you do that in the first instance of human investigation? We can do lots of work in animals, and there has been some work in animals, rodents and non-human primates, but there always will need to be that first instance in humans. How do we think about safety in that context? A lot of discussion from those who are analyzing and critiquing these techniques about interference with nature, so-called, sometimes termed, quote-unquote, playing God. Is this something related to eugenics and how we think about people who have disease, such that we want to avoid people like them being born? Does this imply a kind of societal view about people with disability? Same kind of argument that's being played out in the Down syndrome community. And it goes to a very long-held prohibition that we will not introduce technologies that cross the germline. And I'll say something about where that discussion is going in a second. And the conclusion of the committee, and I'll come to you, Holly, in a second, was that the concerns about human genetic modification or germline modification are obviously important. They warrant significant caution in going forward, but should require the imposition of restrictions rather than anything like a prohibition on going forward with MRT for the purposes of preventing transmission of serious mitochondrial DNA disease. Only because I need to hear you.
You have a slide that had a human on it and had a whole bunch of different things that might go wrong.
Yeah, you want to
And
see that again?
I'm just wondering if you could say a little more about the sort of spectrum of those affected. Is it sort of one yes or no, or is it yes?
The latter. I can't sing like you. So part of the problem is it's a very variable disease, and simply you may not be disease. And anybody here
Syndrome.
work in mitochondrial diseases? I'll quickly be out of my depth. So the 778 number goes to people, women, who have very severe forms, will, without question, pass it on to their offspring, right? So it's a cut of a cut of a cut. It's probably a very common disease across the population in ways that we don't fully appreciate. People think diabetes is a mitochondrial disease, for instance. So mitochondrial DNA disease is a cut of mitochondrial disease, and then these very severe versions are a cut of that.
And do you know you're at risk because you've already had a baby that had it?
Yes, you'll almost never know in advance of having your first child. Sometimes people will say, gosh, now I know my grandma had it. So you can trace it back, but almost no one knows prospectively.
Thanks.
Yeah. So among the things that we determined to be important in the discussion of this analysis about whether it was permissible to go forward and modify at the genetic level in this way, what were important distinctions we thought, between modification of mitochondrial DNA and nuclear DNA. So, as you probably have figured out, this is not editing of any genome. It's the picking up on block of entire populations of intact, naturally occurring mitochondria. And among the features of mitochondrial biology is that there are a limited number of mitochondrial DNA haplotypes in the human population across the globe, fewer than 10. And so you would say, well, that you pick up a population, and you could even say that was of the same haplotype as the woman whose nuclear genome you're keeping, and pull that population from an oocyte potential donor and replace the diseased mitochondrial population with these otherwise occurring intact whole mitochondria. The other things to say include that the traits that are carried in nuclear DNA are the ones that we tend to think about as what makes us who we are. So physical traits, behavioral traits, are not carried in mitochondrial DNA, they're carried in nuclear DNA. Now that's not to say that mitochondrial DNA isn't important. Obviously it is, otherwise we wouldn't have these diseases. Otherwise we wouldn't think about them as being important for how we think about ancestry. But it's different, and we need to sort of tease apart what's important about mitochondrial genetics from nuclear genetics. There were sort of questions about whether one could use these techniques for enhancement purposes. So then you sort of start thinking, how in the world, what would be the way that somebody would use these techniques to enhance offspring? So since mitochondria produce energy, you would say, well, let's get somebody whose mitochondria are really powerful and use those mitochondria so that the offspring would be energetically enhanced. A better athlete is really sort of the implication. But that seems like a whole lot of effort to go through to get a very prospective, if any, benefit. So it seems to be much less potentially problematic than the kinds of things we think about for genome editing, say. And as it says in the last bullet, none of these distinctions imply that mitochondrial DNA is unimportant. It has to be important, otherwise we wouldn't be having the conversations about the terrible diseases caused by certain mutations. But that the difference between MT and nDNA are meaningfully different in a way that matters for the ethics analysis. Now, among the things that would be required for the first human investigations would be making some embryos, human embryos, this way that would never either be intended to be implanted into a woman's body, or were so early on that they wouldn't likely work. And so that's problematic for reasons related to federal policy. So manipulation of embryos, talk about that in a second, using federal dollars is very difficult to do, impossible to do. So one of the things we said was that there are ethical frameworks that already have been crafted that could inform the appropriate boundaries of manipulating embryos for these initial human investigations. Looking further down the road, there's an interesting issue related to equitable access because, like any other diseases, these don't tend to be spread across the population as one might hope. And so you sort of ask, well, how would we make sure if this is something that is available, that it is made widely available to those who could benefit from it? So equitable access is something to think about as the FDA goes forward, but not on the initial clinical investigations. So the sort of elephant in the room, frankly, related to this issue isn't so much the 778, whatever the number is, of births every year that suffer from these diseases, but rather the idea that this technique could be used to help women of advanced maternal age have children. So there's a theory that one of the reasons women of advanced maternal age have a hard time getting pregnant is that their mitochondria are not as active as when they were younger. And so you could easily see, once these techniques are refined and shown to work well, that clinics would try to offer them to women of advanced maternal age. Here's mitochondria from a young woman, preserve your nuclear relationship with your child, but get the energetic benefit of a young woman's oocyte. And so the question then is how to control that if that's thought to be problematic. And so among the things that we said was that regulations and guidelines, so that regulations from the FDA, guidelines from professional societies are needed to limit the use into applications that raise other serious and unresolved ethical issues, like the question of application of these technologies for women of advanced maternal age. So the conclusions from the ethics analysis of this committee were that the ethical, social, and policy issues can be avoided, I'm going to say how in a second, through limitations on the use of these technologies, or are blunted by the differences between genetic modification through MRT and something like editing of nuclear genomes. And so the conclusion from that part of the analysis was that it's ethically permissible to conduct these investigations in humans, but that there are certain conditions and principles that must be met. Okay, so that's now the next phase. Yes, you can go forward, but there are all sorts of limitations and controls that need to be in place for doing so. Before I tell you about that, so part of the environment here relates to the existing laws and regulations that are in place that impact on whether and how embryos could be manipulated in this way. So one is Dickey Wicker, right, which is the ongoing language in the annual budget bill that says you effectively cannot use federal dollars on any research that damages or destroys a human embryo. So that's a limitation on what the NIH can fund. It would all have to come out of the private sector. There's a question about whether it can be reviewed, and I'm going to come to that in a second. So whether the dollars in the federal budget that are used for review purposes could even be used is an open question. There are restrictions on what can be done in research or practice related to what's happening state by state. So in some states this is probably not something that could be carried out. And the FDA regulations, as I'll say a little bit later. The FDA has all sorts of hooks related to quality control, as do states and professional society guidance. So ASRM, for instance, could say these techniques should only be used in this very circumscribed set of criteria. Now, the membership of the ASRM isn't bound by those guidelines, but at least it goes some way in sort of talking about what best practices might be. So now to move to what it would take to conduct ethically acceptable first investigations in humans. So realize this is the first time we will have created children this way. And it goes to a really kind of fundamental question. So we think about informed consent as being an important feature of how we think about research participation. But this is research that will create a child. There isn't anybody to actually ask for consent in terms of the affected party. Of course, the intended parents are affected, but in a very different way. So the first thing that would need to happen is that initial safety is somehow established, and the FDA needs to figure that out. So you're going to say, what would that look like? And the answer to that is a committee that's comprised of about the ethics and social and policy issues isn't able to answer the question about what initial safety standards need to be met. But the FDA knows how to do that, right? That's what advisory committees of the FDA do every day. Okay? We also said that the risks to the parties involved need to be minimized, and most importantly, that risk to future offspring occupy the highest priority consideration in minimization of risk. So if there's a choice to be made, minimize risk to the potential offspring first and foremost. There needs to be some strong likelihood of efficacy established by preclinical, that means animal research. And as I said before, there's a fair amount of rodent research, much less non-human primate research. There really is, frankly, quite limited data in the preclinical context, and the FDA will need to make a decision about when they have enough. But once they do, so safety and efficacy established from preclinical data, then go forward first with humans, limited to women who are at risk of transmitting, so this is all these questions, serious mitochondrial DNA disease, right? The pathogenicity is undisputed, so you know it's going to be passed on, and the disease that you get from that mutation is predicted to be severe. And there are syndromes that are really quite horrible. So that's the 778 number by, obviously it's an extrapolation. Here's the most controversial of the recommendations. So to reduce the risk of adverse effects being realized by multiple generations, so this is to avoid the heritable genetic modification, the committee recommended that transfer be limited to male embryos only, in the initial clinical investigation in humans. No females. So you say, well, that sounds like sex selection. Well, it sounds like a way to make sure that we don't get heritable genetic change, but we still can help people who suffer from these diseases see a way to have genetically related children. So that's to put it in a much more positive way. But this got a lot of attention, partly because it sounds like sex selection, and partly because the UK did not institute such a restriction. Right, I'll talk much more about this when we have our questions and comments. In addition, we said if the intended mother, the woman who wants to be the mother of the offspring, will carry the pregnancy, and that's not always likely to be possible because they have their own health issues. There needs to be a medical determination by someone that she would be able to complete a pregnancy without significant risk of serious adverse health consequences to her. So even if she wants to do it desperately, there needs to be a medical assessment. That the investigations can be carried out only by investigators and at centers with demonstrated expertise and skill. If you remember, I mentioned this problem of carrying over mutagenic or pathogenic mitochondrial DNA. So the physical actual taking away, so when you suck out, right, you only want to take this nuclear DNA, but there's cytoplasm around it, and you want to take as little of the cytoplasm as you can, but you can't take none of it. It just isn't possible, and so that's what this little mitochondria is meant to represent. You're going to carry some pathogenic mitochondrial DNA with you into the new reconstructed egg. And so you want this to be done only by people who have the expertise to do it right in the way that will carry over the least possible pathogenic mitochondrial DNA. Otherwise, you've not achieved anything of the goals that you've set out. Okay? So limited to very few places. And in the UK, they're able to do that very easily because of the way that HFEA does its work. In the US, not so straightforward. So we have a much harder time limiting reproductive technologies to only some number of centers, right? There's a proliferation that will happen relatively quickly. And then lastly, on this slide, that the FDA has does some analysis of the potential for mitochondrial DNA haplogroup matching. So remember I mentioned that there are only some number of limited universe of mitochondrial DNA haplotypes in the world. So one thought is there's been an evolution of nuclear and mitochondrial DNA, and maybe the haplogroup matters such that you don't want to cross haplogroups. You want somebody's nuclear DNA to sort of match up with the mitochondrial DNA haplogroup from which they arose. But there's no science that actually supports that yet, except in Drosophila, literally. And so there needs to be some science evaluation of whether that's worth doing, and if so, consider implementing that as a part of the protocol for these first investigations in humans. I think I said enough about this, except to say, because so few such children would be born in the US or in centers around the US or across the world, that there needs to be some standardization to the extent possible to enable comparisons and pooling of results. So that you don't say, well, yeah, that looks like it was okay in the UK, but using a different approach here in the US, and we can't compare apples to oranges. And then, really interesting, that's something the FDA doesn't like very much, is an urging that clinical practices from outside of FDA jurisdiction should be incorporated into their analysis. So take advantage of what's being done outside the US, most likely in the UK, and incorporate that into your analysis about going forward in our country. They bristle about that, actually. And then how to think about going forward in a way that would affect not just the initial investigations, but any investigations of these technologies before they are, if they're ever licensed for approval across the population. There should be a collection of long-term information about the children, their health, psychological, and social effects, including their own perceptions about their identity, ancestry, and kinship. Now, that's an interesting one. So how do you think about that from the perspective of consent? Talk about So because the data for in support of going forward as human embryos are used, there needs to be a kind of ethical provenance of that data so that the results come from embryos that were either created or used in ways that would follow certain guidance. And you'll see here that second bullet says non-viable human embryos should be even possible for preclinical research, but at some point viable human embryos are going to be necessary, and it says there only when required and in the smallest numbers possible. So this goes to how does the FDA think about requiring what is effectively the creation and destruction of human embryos in support of an analysis for either first human investigation or eventual licensure. They've never been faced with that before. It's quite problematic for them in the political context. Okay, so that you don't think we were short-sighted and said stop with males. We said it isn't the case that we think only males should be created this way, but rather in initial investigations that's the way to make sure that you aren't unleashing into future generations something you didn't expect. We said it could be permissible to go forward and implant female embryos if the following three conditions were met. One, that there's clear evidence of safety and efficacy from male cohorts, so that's available from across the experience in the rest of the world and the US. That preclinical animal research shows evidence of intergenerational safety, whatever that looks like. Again, what's that science look like? But somehow having a bit of confidence that we aren't creating problems that would be heritable. And then, maybe most important for this story, we realized as we were doing the work of this committee that there was another committee being formed, which is now in the midst of its work, which relates to use of gene editing tools for human purposes. And so we didn't want to get crossways with the work of that committee, on which I also serve, full disclosure, although thankfully I'm not chairing that one. That's a real handful, to be honest. But we said, so decide to go forward in ways that would actually create heritable genetics change only when that decision is consistent with the outcomes of other deliberations, meaning the international deliberations that are happening now, to establish a shared framework concerning heritable genetic alterations, such as the use of gene editing. So that was really a nod to wait to what's coming out of this other committee's work, which will be done with its, will issue its report by the end of calendar 16, so it's not so long to wait. So you need to be sure that you're doing this in a way that will be safe, and then you need to do it in a way that is consistent with what other committees are thinking about the ethics of germline modification. I'll finish up here. So informed consent poses a special problem in some respect, right? We can't get consent from people who are not yet existing. And one thing we said is and you don't need to, is pretty much the answer. So parents need to give consent, clearly, those who intend to be parents, and there needs to be special attention to communicating the novel aspects of these technologies to those who would be the participants. So that includes those who are donating gametes, so it's possible you could have both oocyte and sperm donors. The people who intend to be the parents of those offspring, and then when those children are born, if they're born, that they give their assent to long-term monitoring and follow-up, and then when they reach the age of consent, that they are asked for and either give their consent or opt out of follow-up. So they can only be encouraged, and the parents can only be encouraged to allow their children to be followed, but you can't force that on individuals, of course. So sort of problematic in the way we think of consent, at least for in advance of offspring being born. So a few sort of high-level principles for how to think about oversight of this area of research, not just in the first human cases, but if it moves forward, as it moves forward, that there be a few things adhered to. One, transparency, that there be public sharing of information from the results of these studies, and that those who are sponsoring these protocols, these trials, would need to commit to depositing the protocols and the de-identified results in publicly accessible places, that there be public engagement of stakeholders, including public meetings and Ruth asked when the report was issued. It was February 3rd, as you'll see in a second, but we had a public dissemination event just a week ago today, where there was more opportunity for people who wanted to share their views with us about the report to do so, and they did. That there be a collaborative effort with other regulatory authorities, most notably the UK, and as I said before, that there be a way to maximize data quality by enabling cross-referencing and pooling of data. Among the hardest things for the FDA to do as a matter of our recommendations was this one about circumscribed use. And what we said is FDA should use the means at its disposal and all of the means that it has to limit the use of these technologies to the indications, individuals, and settings for which it is approved and no more. So this is the problem of off-label use and the expanded use of these techniques for things like women of advanced maternal age. And then we said, and if there's a decision or a thought about a decision to expand, to engage the public in a fresh ethical analysis of any decision to do that. All right, so the committee released its report on February 3rd, as the academies do, a public event in Washington. There was a fair amount of media coverage, I think less than might have otherwise been the case because of gene editing having sort of, in a way, an umbrella. It's an umbrella for this and other kinds of issues. Generally positively received, except the UK folks got a little up in arms about our analysis related to both limitation to male embryos and the analysis that says MRT represents heritable genetic change. So the UK analysis said it doesn't present heritable genetic change, that the only way you get heritable genetic change is by modification of the nuclear genome. So we didn't agree with that, and you can read about that analysis if you are so interested. Now, maybe most interesting, so the FDA receives the report, and there was then a fair amount of media interest, and I think it was actually Rob Stein at NPR who asked the question of the FDA, what do you make of the language in the budget bill? So it turns out President Obama signed in December of last year, right, a budget bill which included the language that I have just quoted here, right? So you see it's the section 749 of the Appropriations Act. None of the funds made available by this act may be used to notify a sponsor, so that's the FDA, or otherwise acknowledge receipt of FDA, a submission for an exemption for investigational use of a drug or biologic product, so that's an IND application, in research in which a human embryo is intentionally created or modified to include a heritable genetic modification. Any such submission shall be deemed to have not been received by the Secretary, and the exemption, the IND application, and the license may go into effect. Now, and I think many of us who are paying attention to this would think that this was meant to apply to gene editing, not to mitochondrial replacement. Because you could say implantation of male embryos only does not violate that language. But the FDA counsel's office did not agree. So as I said just a week ago today, we had a public dissemination event. It was actually part of the contract that the FDA let with the Institute of Medicine, that there be some weeks after the report release a public dissemination event, and it included a presentation by the FDA, Celia Whitten, who is the director of the relevant office within the FDA that oversees gene transfer and would oversee MRT. So she said there are many actionable recommendations, actually very happy with the report. However, this is what she said, the decision on the part of the FDA is that the budget bill language prevents considering applications during the current budget year. Now realize it was language inserted in the budget bill. And so their view is it could be gone as of the next fiscal year. Now people, I think, thought the same thing about Dickie Wicker, which is just gets rolled into the budget bill every single year ever since, and that started in 1984, if I remember my years correctly. So her point about male embryos only, saying, well, it's possible to limit the transfer to males only. It's impossible to limit the creation to male embryos only. Right? We don't have a way to identify just the Y sperm and only fertilize the eggs with those Y sperm. And therefore, you would be creating an embryo in a way that returning to what the Gene Editing Committee, as it's known as, which is it's an international member committee that's been convened by the NAS, National Academy of Sciences, the National Academy of Medicine, the Chinese Academy of Sciences, and I want to say the Wellcome Trust. So that's got international representation, which is focusing among its charge, including issues related to the ethics of the use of gene editing tools in human contexts. So we'll get to an answer to that question. We have to, as part of the work of that committee, which will then inform whether one might go forward if the FDA ever thinks it's permissible with implantation of female embryos created through these mitochondrial replacement techniques. That's all I have in my slides. Yep, 15 minutes left. You can throw stuff out and whatever you like. Layla. Many of you have been paying attention to this, I know, so you have thoughts.
Well, this is maybe a minor point, but it sounds like for many good reasons that you just described, your committee recommended to try to restrict this to a minimum number of cases where the need is pretty compelling, at least to begin with, in an investigational context. And I just wondered if you could talk a little bit about the tension between that and the need to establish a robust safety and efficacy data, and how hard it will be to really monitor adverse events at scale if it's
This is an unusual kind of trial, right? So part of this is we've never been a trial like for reproductive technology, so how do you even set that up? And part of what you want to know relates to very long-term longitudinal information about those children. And so the FDA has said, not publicly, but I don't think it's out of school to say, we're thinking about this in 10, 12, 15, 20-year timeframe. We're not going to approve this for licensed use anytime soon at all. And the question will be, how many do you need to, as you say, get sufficient data? So the first, I presume the very first cases will be very small in number, because if it doesn't go well, you obviously want to restrict that to a very small number until you refine the technique. So, all of that's going to be up to them. So among the things that's a little challenging is this committee was convened. So it's not a narrow charge, but it's a limited charge. And there isn't a parallel committee, except the FDA advisory committee process, charged with all the questions about science and how much and what constitutes sufficient data. But all of that needs to get worked out. Now, FDA will say, we know how to do that. Leave it to us. You just need to tell us how to do it in a way that's ethically permissible, which is what we did. And I think the good news is they seem to like the report and its recommendations such that it will have traction not just for MRT, but other more manipulative reproductive technologies coming down the pipe. Presumably at some point, maybe not, but presumably at some point the budget restriction will be gone, and they'll be able to think about how to do this. You guys have the microphone, so 9 people.
One of the things I found most interesting about your guidelines was the concept of assent or consent from the children that result from this technology. In my individual clinical experience working with assisted reproductive technology, often parents really don't want the child to know they weren't conceived the old-fashioned way. Is there a requirement within the consent that the parents, are they going to have to disclose that to the child? Because one of the things they're going to be involved.
They don't have to. So there's a lot of encouragement. And so obviously I didn't say much about the details, but if you're interested, there's a whole section in the report about informed consent and what it needs to include. So among the things, strong encouragement that there be permission to follow up their children from birth, and then that they be asked for their assent and then eventually consent. So that would mean they would obviously need to know. So it's part of what is part of the consent. We need this, and for all these reasons, it's important. The other, interestingly, included in what we thought was appropriate and important in the consent process was that this would likely be something that would receive a fair amount of media and public attention, and that we need to even under the best circumstances and confidentiality attempts to be maintained, it's very likely that it would be first instances that they would be instituted. Now, if and when they become something a little more pedestrian, they become refined and a part of a process, then they start to look a whole lot like IVF and ICSI and other things. And we don't require that kind of heavy consent process in those cases. Now, one of the arguments is, we should have been following those kids. And the UK, has actually done much more of that than we have. And so this is introducing something that's a little bit closer to what the HFDA has done with reproductive technologies than what we have done in the past. So it will be quite different than what we've experienced, but I hope for the better. Ruth?
Jeff, could you highlight a little bit more the FDA's position with respect to the wider
Yeah.
I'm confused. Are you saying that the FDA will allow research that destroys embryos to be
They
included
don't
in
think-
an IND, or they won't allow it? And so can this work forward or not?
So, sorry, I cut you off.
No.
So their view is that Dickey Wicker does not prevent them from reviewing data that may have come from embryos that were created and destroyed. So created for research and destroyed in the process of that research, so long as the funding for that research didn't come from public sources. So they don't believe that their review would be limited. This language is a different matter. So no, they don't believe that Dickey Wicker applies to them. The other thing that's a little bit unclear is whether this research would have to go through the RAC, so the Recombinant Opinion Advisory Committee, right? So is it gene transfer? You are transferring, right, genetic material. It's not a person yet, right? Although if it's a fertilized egg, then you're getting into all of that question. So the NIH has actually been really coy about whether it would have to go through the RAC resistance. And that would be like other gene transfer. The FDA reviews it separately from the RAC, and then they share information.
So just to get clear,
Yeah.
is it the case that this new language for this new, because of this new insertion in the budget bill, means the FDA is not now going to allow data from this research to be included in IND, which basically stops it?
Yep.
So right now, there's effectively no way legally that
Can't be done.
it can be done
Right.
if the purpose is to go forward to get.
Correct. So, and this is not just a sort of speculative, what if. So, Metal, there's a guy at Oregon Health and Science Oregon Health and Sciences University, who wants to pursue this. And it has, either there's an IND sitting at the FDA or he's ready to submit it. But the council's decision effectively prohibits them from reviewing that IND application, period.
One last question. If an investigator or physician wants to do this, it's not illegal. They just can't get an IND, but they could do it. There's
Yeah,
no,
I mean, so
they do it, so it's like getting reproductive technology developed in general. There's
Correct.
nothing stopping anyone in the United States.
correct. Now, the
Going
FDA,
forward. Okay, just want to be clear.
it's not exactly true. So, I'll say why.
Okay.
So, Jacques Cohen, anybody from that world in the room? So, there's a guy in reproductive medicine who used to be a St. Barnabas, very woman, Jacques Cohen, who did something that was a little similar for women with advanced maternal age. He got women who were younger to donate their eggs and then remove some of their ooplasm, sucked it out, and then injected it into the eggs of women of advanced maternal age, fertilized those, and then implanted them, and has, I think there's 24 children that were born that way. So it's a mix, right, of mitochondria from the donor woman and from the woman who wants to be the mom. The FDA intervened and said, that's more than minimal manipulation. If you're going to do that and offer it for sale in your clinic, you need to go through FDA approval. So either submit an IND or stop, and you stop. So presumably they would say the same thing. If it were found out to be the case that there were a clinic trying to do this somewhere in the U.S., there would be an FDA letter showing up on the doorstep.
Has it been successful elsewhere in other countries?
Has it been successful? So
Yeah.
child born through this technique. So the place that's furthest along is in the UK. So the UK, as I mentioned very briefly, went through a quite long process of public engagement to figure out whether the public was in support of this going forward. In the UK, they took that information. There was a parliamentary vote where Parliament approved it, and then that then gave the HFEA, which is a single licensing authority in the UK that has, if you wanted to do anything with the human embryo, make or use a human embryo in the UK, you have to get a license from the HFEA. So the HFEA now is in the process of crafting guidelines by which people could then apply to them for a license to do this in a human. And they will do that on a case-by-case basis. So one woman, one clinic, one license. And once you use that up, you have to then come back for another woman, another license. So it isn't even a license to the clinic. It's a license to the combination of the clinic. We think you can do this in a way that's responsible and successful. You have the skill, and we think this woman satisfies criteria that are very much like the ones that we articulated, actually. And if those two are met, then go forward. And the guy who's going to do that is named Doug Turnbull. He's the one who everybody knows is the expert at Newcastle in the UK. And so once that happens, there'll be a baby born, and we can then have a conversation about whether it was successful and if there are any ill effects and all the things you're probably thinking about. Yeah. But until then, it's anybody's guess, and all we have is animal data, and really very, very little animal data so far. Now, let's see if you have a microphone.
I do, yeah. So a quick question, something that I don't understand, and maybe you don't understand either, is for the UK. The UK analysis, I assume this was done by the HFEA, that said this doesn't constitute a heritable genetic modification. And I'm trying to understand how they could stick to their guns that this is literally true. So on the one hand, I can see that there's a case for interpretation on this isn't heritable genetic manipulation that matters, or something like that. But it's heritable internally, it's genetic, and it's modification. So I'm just trying to figure out what it is they're really saying. Are they really trying to go for that matters, or do they know something that I don't? So.
I'm going to answer in a way that's not exactly an answer. So there's a prohibition in UK policy on germline modification. So if it were under an analysis or defined as a heritable genetic modification, it would be prohibited in the UK. And they didn't think it should be prohibited in the UK. So they made a fine distinction, right? That we think genetic modification means the modification of nuclear genomes, not mitochondria. So they stipulated it. And I think that the folks at the Nuffield Council, which is their standing council on bioethics, would say we don't think it stands up to conceptual analysis, but we understand why. And it's more or less the differences between mitochondrial and nuclear DNA matter, right, in the way that I roughly outlined. And that's enough to say this is okay to go forward, but that is not, which is pretty much what we said too. But we thought it was disingenuous to say it didn't constitute heritable genetic change. Rachel.
Thanks, Jeff. I have a question about whether there was any discussion on this committee of the distributive justice questions inherent here, in terms of resource allocation for this technology to allow one to have a genetically related child, as opposed to allocating those resources in another way, or if that's sort of beyond your purview.
You're not the first to ask that question. And I wouldn't say it was beyond our purview so much as the FDA isn't in the business of receiving ideas and saying, we think this is a worthy place for someone to invest their money versus not. It's not the way the system works. So if Alabama or someone else submits an IND, their job is to evaluate it on the basis of the Food, Drug, and Cosmetic Act. So one could make an argument about whether it's an appropriate investment of resources, but that isn't sort of the level of evaluation analysis that the FDA does, and so therefore our recommendations that they actually said to us, we had this conversation, they said don't say anything about that. It's not relevant to our decision about whether to proceed with receipt of a license request, let alone an evaluation of a potential approval.
Are there shared symptoms which lead people to presume that somebody, that a newborn has
sat and listened to the physicians, describe them, and you would say those sound horrible.